Hello everyone, today we are going to do the detailed estimation of the slab culvert having the span of 1.5 meter and the roadway of 4 meter. In this question we have this half sectional plan view. We have half sectional elevation on ABCD and we also have this half longitudinal section on CBEF. Firstly, we have to understand what is the abutment and the wing walls. In this half sectional plan, we can clearly see that we have these 4 wing walls. That means this portion is our wing wall, this portion is also wing wall, this portion is also wing wall, and this portion is also wing wall. Whereas we have 2 abutments, that means this portion and this portion. So here is a 3D view of the slab culvert, and we can clearly see that these are the wing walls. This is also wing wall, and here are 2 wing walls. Similarly, there is the abutment portion here and here. We have this roadway of length 4 meter, that means from this portion up to this portion is 4 meter. And we have these parapet walls on both sides of this slab culvert. And this is the earth slope of 1:1. And we can clearly visualize these abutments from this bottom side. Now let's visualize this half sectional elevation on ABCD. When we cut this half sectional plan from this portion, that is ABCD portion, then it will look like this. So when we see this object from this front view, it will exactly look like this. That means this portion, that is this 1.2 meter portion is this portion, this 70 centimeter portion is this portion, and we have this brickwork in this portion, and we have this RCC slab portion. Here we have this RCC slab portion here, and these are this parapet wall, that means these parapet wall portions. And we have this earth slope of 1:1, that means here also 1:1, and here is the hidden line. And we have this ground level, that means this is our ground level. In our question, we also have this half longitudinal section on CBEF. It means that when we cut this plan from the CBEF portion, it will look like this. Here is the CB section and here is the EF section, that means our CBEF section. And when we view this object from this front view, it will look exactly like this. Here we have this coping in this part, and this is our 30 centimeter width parapet, and this is our 40 centimeter width parapet, and this small portion is our 10 centimeter wearing coat, that means this portion. And these are the brickworks, and these are the lime concrete portion. This is also the lime concrete portion, and this is our bed level. And when we view this object from the front view, this portion will appear rectangle. So it look like rectangle here. Now our first step is to calculate the earthwork in the excavation, in the abutment as well as the wing walls. So we can see that we have to calculate the excavation of this portion, that means 70 centimeter width up to the ground level. That means up to the height of 30 plus 30, that is 60 centimeter height. So for this excavation work, we need to calculate the length of this abutment from this point up to this point, that is we will get this length from this point up to this point, and we have to do the excavation up to the ground level. So our total length is 4.8 plus 15 centimeter plus 15 centimeter. So our length is 4.8 meter plus 2 times of 0.15. So we get our total length 5.1 meter. We have 2 number of abutment walls, that means from this portion and this portion. So number equals to 2, length equals to 5.1. The width is 70 centimeter, that is we have to do the excavation of 70 centimeter width. So width equals to 0.7 meter, and the height is up to the ground level. That means 30 plus this portion is also 30, that is 60 centimeter. That is 0.6, and we get our quantity 4.28, and the unit is cubic meter. Here we have already done the excavation of this abutment portion from these 2 abutments. Now we have to do the excavation in this wing walls portion, that means these 4 portions here and here. So we need the length of this portion to this portion, and we have already this length 1.2 meter, and here also the length is 1.2 meter, and we have this width of this excavation 0.7 meter, and the height of excavation is 60 centimeter, that is 30 plus 30 equals to 60 centimeter. So we can easily write the numbers equals to 4 and the length equals to 1.2 meter, which is already given. So length equals to 1.2 and the width is 0.7 and the height is 0.6 meter, and we get the total quantity 2.02 and the unit is cubic meter. Now our next step is to calculate the cement concrete in foundation. Here we can clearly see that the cement concrete in foundation is this portion, and these portions, and it is up to the height of 30 centimeter. That is, this is of 30 centimeter height, and we will get the same length but only the height will be different. That is, we have the height of 0.3 meter and we have two numbers of this abutments having the length of 5.1 meter, that is same as this method, and the width is also same and the height is 0.3 meter, that is this portion, and our total quantity is 2.14. The unit is cubic meter. And here in this wing wall also we have numbers for the length is same, that is 1.2, breadth is 0.7 meter and the height is 0.3 meter. So the total quantity is 1.01 cubic meter. Now our next step is to calculate this first class brickwork in 1:4 cement mortar. That means these brickwork portions, this also and this also. Here we can see that we have this brickwork in this portion, but we don't have this brickwork in this RCC slab, so we have to reduce this RCC slab later. Here we have to do this brickwork in this hatch portion. That means this 40 centimeter width and the length is 4.8 meter. That is from this point up to this point. So we can write the length equals to 4.8 meter and width equals to 40 centimeter. So the number of abutments 2, length equals to 4.8 meter, width is 0.4 and the height is, we have to see from this half sectional elevation, that is our total height of this brickwork is from this point up to this point. That is, we have this length 30 and this length is 1 meter and this length is 20 centimeter. This 20 centimeter can be easily seen from this half longitudinal section on CBEF. So this slab portion is 20 centimeter. This portion is 20 centimeter. So the total height of the brickwork is 1 meter plus 30 centimeter plus 20 centimeter. That is 1.5 meter. So I can write the height as 1.5 meter and our total quantity is 5.76 cubic meter. Now we have 4 number of these wing walls and we have to find the length. So for this we need to calculate the length from this point up to this point, and we have this length 1.2 meter and this small length is equals to 0.7 minus 0.4 by 2, that is 0.15 from this side and 0.15 from this side. And here also we have this 70 centimeter wall and there is 40 centimeter wall, so this portion is 0.70 minus 0.40 by 2, that is 0.15 on this side and this side. So we have all these small lengths 0.15 on all these sides. So the length of this portion is 1.2 plus 0.15 minus 0.15. So we get the length 1.2 meter here also. And our width is 40 centimeter, that is 0.4 meter width. So I can write the length 1.2 meter and width is 0.4 meter and the height is same as before, that is 0.3 plus this length is 1.3 and this slab portion is 0.2, height is 1.5 meter, and we get the total quantity 2.88 and the unit is cubic meter. Now we can see here that we have this parapet portions and these are also considered as the brickworks. Here also we have this brickwork portions, so we have to find the length of this brickworks. Here we have this length 4.9 meter from our half sectional elevation on ABCD, and this is our 10 centimeter coping from this side and here also 10 centimeter coping, but the actual length that we require is from this side up to this side because here is our parapet portion. So this length is 4.9 minus 0.1 from this side and 0.1 from this side, so our length equals to 4.7 meter. And in 3D this length is from this side up to this side and the width is 40 centimeter. So we have parapet up to the curve 2 in number, that means this portion and this portion, 2 parapets on both sides, and we have this length L equals to 4.9 meter minus 2 times of 0.1, that is 4.7 meter. and we have this width 40 centimeter parapet, so width equals to 0.4. And to calculate the height, we have this 40 centimeter width from this level up to this level. That means this height is 20 centimeter and this small portion is 10 centimeter wearing coat, so the total height of 40 centimeter parapet is 30 centimeter. That is, this portion is 30 centimeter. So we can write the height equals to 30 centimeter. So we get the total quantity 1.13 cubic meter. Now we have to do this parapet above the curve. We consider this portion as the parapet above the curve because we have here curved portion, and we have to calculate this length from this portion up to this portion. So we have two number of this parapet from this side and from this side. So number equals to 2. We have the same length from this parapet as well as from this parapet, so length is 4.7, but we have the width of 30 centimeter. For the height, we have this 30 centimeter parapet from this portion up to this portion only, but we have the height of 60 centimeter from this height up to this height. That means we have to reduce this 10 centimeter coping, so our total height is 60 centimeter minus 10 centimeter, that is 50 centimeter. So we have this height of 0.5 meter and the total quantity is 1.41 cubic meter. Now we have to do this parapet coping, that means from this portion up to this portion. So here we have this total length of 4.9 meter and the width of this coping is 0.4 meter and the height is 10 centimeter, that is 0.1 meter. So we have two number of parapet coping, that means from this side and this side, and the length equals to 4.9, width is 0.4 and the height is 0.1. So our total quantity is 0.39 cubic meter. Now we have to deduct this small portion RCC slab on this side and on this side because we don't do brickwork in this portion. That means we have to reduce this small portion from our brickwork. That means we have this portion, that is the width of this bearing, that is 0.3 meter from both sides up to the height of 20 centimeter, that is 0.2 meter. And for the length, we have to calculate the total length from this side up to this side. That means the total length from this side to this side. So we have this total outer to outer length 4.8 meter. That means this portion to this portion is 4.8 meter. So we have to write the length equals to 4.8 meter. That means from this side to this side we have the RCC slab. So we have two number of this RCC slab, that means from this side and from this side, having the length of 4.8 meter. So length equals to 4.8 and the width is 0.3 meter, that means this portion, and the height is 0.2 meter, that means this 20 centimeter. So we get the total quantity 0.58 cubic meter. Now our next step is to calculate this RCC work excluding steel and bending but including centering and soldering. That means now we have to consider this RCC slab, and we have already calculated the length, that is 4.8 meter from this side up to this side, 4.8 meter. So length equals to 4.8 meter and we have to calculate its width. Here we can clearly see that we have this RCC slab from this portion up to this portion. That means we have this total length 1.5 meter plus 0.3 plus 0.3, that is 1.5 plus 0.3 times of 2. So we get our total width 2.1 meter. B equals to 1.5 plus 2 times of bearing of 0.3, that is 2.1 meter, and we have this RCC slab of 20 centimeter. This portion is of 20 centimeter. So height equals to 0.2 and we get our quantity 2.016 cubic meter. Now we are doing this steel bar including this bending in this RCC work. It means that in this RCC slab we have to insert the steel bars of 3 types. That means of main bar and main bent up bar and distribution bars. So firstly we are going to calculate this main bar of 20 mm diameter. That means we have this 20 mm diameter main bars at the spacing of 15 centimeters center to center. So it means that we are going to put this main bar in whole of this RCC slab having the center spacing of 15 centimeter. And to calculate this number of how many bars that we have to put in this RCC work having the diameter of 20 mm, we have the formula, and that is number equals to length divided by center to center spacing plus 1 in the main bar. That means we have to put this steel bar from this portion up to this portion, and we have calculated this outer to outer length, that is 4.8 meter. That means this portion is 4.8 meter, and we have this center to center spacing 15 centimeter. So number equals to 4.8 divided by 15 centimeter, that is 0.15, and we have to add 1 for the main bars, so plus 1, and we get the total number 33. Now we are going to do this 20 mm diameter main bar of 15 centimeter center to center. There is a steel bar here, and this portion are called the hooks, and we assume this small hook is of 9 times of the diameter. Firstly, we need to calculate this outer to outer distance. That means 1.5 plus 2 times of 0.3 meter, that is 2.1 meter from this side to this side, and we have to assume that these hooks are of 9 times diameter on both sides. So the total length equals to outer length 2.1 minus this cover of 4 centimeter from both sides, and again add this hooks of 9 times diameter from both sides. So I can easily write the length as 2.1 minus 2 times of 0.04 plus 2 times of 9 times of diameter, and we have the diameter of 20 mm, that is 0.02 meter. So the total length is 2.38, and we get the total quantity 78.54 meter. And our next step is to calculate this main bent up bar, and we calculate this number same process, but we don't need to add plus 1. That means our number equals to length divided by center to center spacing, and plus 1 is not needed. And we have this bent up bar of 30 centimeter center to center spacing. We provide bent up bar in this whole RCC slab, so length equals to 4.8 meter divided by center to center spacing is 30 centimeter, that is 0.3, that is number equals to 16. And here we provide these bent up bars at the top. That means we can clearly see that the length of this bent up bar is more than the length of this straight bars, and we assume this small bent up portion 16 centimeter. So in this straight main bar we have to add 16 centimeter to get this bent up bar portion length. The length equals to 2.38, that means the length of the straight bar plus 16 centimeter, that is 0.16, and the total length is 2.54. So length equals to 2.54, and our total quantity is 40.64 meter. And we assume that the weight of these steel bars of main bar is 2.47 kg per meter. So our total weight of the steel is 119.18 into 2.47. So we get the total weight 294.375 kg. Now we have to calculate this distribution bar of 10 mm. That means here we can see that there are the distribution bars of 10 mm diameter and 25 centimeter center to center spacing. That means these distribution bars are laid in this RCC slab. So we have to calculate this length. That means this portion is 2.1 meter, and we have this spacing of 25 centimeters center to center. So the total number of this is, we have the length 2.1 divided by center to center spacing, that is 0.25, and we don't need to add plus 1. So we get the total number 8.4, which is nearly equals to 9. So we can write this number 9. That means these distribution bars are kept all over this RCC portion like this. So we have to calculate this length of this steel bars, and the length is, this portion is 4.8 meter, and we have to reduce these two cover from both sides, and we have to add this 9 times of diameter, that is the hook portion from both sides. So length equals to 4.8 minus cover of 4 centimeter, that is 2 into 0.04, and plus 2 times of 9D, and the diameter of this distribution bar is 10 mm. So into 0.01, that is 10 mm. So the total length is 4.9 meter, and we get the total quantity 44.1 meter. And we have these 4 number of this top distribution bar. So the top distribution bar number is 4, and the length is same, that is 4.9 meter as above, and we get our total quantity 19.6 meter. Now we have to calculate the weight of the steel, and we have to calculate the weight of the steel at the rate of 0.62 kg per meter. So we get the total weight 39.49 kg. Now our next step is to calculate this cement concrete of 1:2:4 wearing coat. Here we have this wearing coat in this layer. That means here we can see that there is a 10 centimeter wearing coat from this portion up to this portion. That means the total length of this wearing coat is 1.5 plus 0.4 meter width of this wall and plus 0.4 meter width of this wall. That is 1.5 plus 2 into 0.4. That is the width is 2.3 meter. That means this portion is the width of the wearing coat, but we have this wearing coat all over this roadway width. That means we have the roadway width of 4 meter. That means here is the roadway of 4 meter. So the length of this wearing coat is 4 meter and the width is 2.3 meter, and we have the height of the wearing coat 10 centimeter, that is 0.1. So the total quantity is 0.92 and the unit is cubic meter. Now we have to calculate this cement pointing of 1:2. Firstly, we have to understand where is this cement pointing applied. So this cement pointing is applied over this exposed area. That means all this exposed portion. So firstly, we need to calculate the cement pointing from the face wall from ground level up to the bottom of the coping. That means we are going to do this pointing in this surface and we are going to consider this full rectangle, and later we will reduce this rectangular portion. And while doing this pointing, we have to assume that below the ground level we have to do the pointing up to the height of 0.1 meter. That means we have this portion as ground level, and below the ground level, that means this portion is 0.1 meter, and we have to do pointing up to 0.1 meter below the ground level. That means we are going to do this pointing from this portion up to 0.1 meter below the ground level. That means this portion up to this portion. So we have this length 0.1 meter and this height is 1.5 meter and this portion is 0.6 meter, but we do not do pointing in this coping, so we have to reduce this 0.1 meter height. That means this portion is 0.6 minus 0.1, that is 0.5 meter, and we will get this total length 2.1 meter. And here we can visualize this figure here. That means this portion is 0.1, this height is 1.5 meter, and this portion is 0.5. So we are going to do pointing up to this height, that is 2.1 meter height. And we have this full length from this portion to this portion is 4.7 meter. That is 4.9 minus 0.1 and minus 0.1, that is 4.7 meter. And we are going to do this same pointing on another side. So we have numbers 2 having the length of 4.7 meter, and it doesn't consist of the width, so the height equals to 2.1 meter, that is h equals to 0.1, that is below ground level, plus 1.5 meter plus 0.5 meter, that can be clearly seen from this figure. So height equals to 2.1 meter, and we get our total quantity 19.74, and the unit is meter square. Now here we have already done this pointing on this surface and this surface. Now we are going to do this pointing in these inner sides of this parapet, excluding this coping. That means this side and this side. That means we have to see the height of this portion and the length from this point to this point, and we have to consider this 10 centimeter projection from the top side. We have already the height of 80 centimeter from this point to this point. That means this total height is 10 centimeter, that is the top projection, plus 80 centimeter, and we have to reduce this coping of 10 centimeter height, that is the total is 80 centimeter height. And we have this length from this side to this side is 4.7 meter, that we have already calculated by 4.9 minus 2 times of coping of 0.1 is 4.7. So we can easily write that length is 4.7 and height is 80 centimeter. So we get the total quantity 7.52 meter square. That means we have done this cement pointing on this side, these two inner side, but we have not considered this coping. So now we have to do this coping from this top side and this inner portion. So we have the number of coping 2 in number, and the total length is 4.9 meter. That means this length is 4.9 meter from this side up to this side. So I can write the length equals to 4.9 meter. Now we are going to do pointing on all these top sides, these edges, and also this projection. So we have this total length 4.9 meter, and we have this length of this coping from the top 0.4 meter. That means this portion is 0.4 and this side portion is 0.1 meter, and here also 0.1 meter, and this small projection is 40 centimeter, wall minus 30 centimeter, wall equals to 10 centimeter. So we get the total length of this coping 10, that is 0.1 meter plus 0.4 meter plus 0.1 meter plus 0.1 meter. That means this portion is 0.1, this 0.4 is this top portion, this 0.1 is this side portion, and this 0.1 is this projection. So we get our total width 0.7 meter, and we have this coping on both sides. That means here also we have this same length, so we have to consider two numbers of this coping, and we get our total quantity 6.86 meter square. Now the only part we have left is this side portion, this side portion, and this side portion, and this side portion. Now we are going to do this cement pointing on these ends of the parapet, that means this portion. So we are going to do this ends of the parapet, that means these two portions from one side and another two portion from the back side. So we have this total number 4, that means these two and the back side 2, so number equals to 4, and we have this width, that is 40 centimeter width of this parapet and up to the height of 20 centimeter, that means this portion. So we have the number 4 and we have the width of 0.4 and we have the height of 0.2 meter, that means this small portion. So we get the total quantity 0.32 and the unit is meter square. Now we are going to do this ends of parapets of 30 centimeter, that means this portion, and the back side 2 portions. So we have the numbers 4 and we have the width of 30 centimeter up to the height of 50 centimeter, that is this coping is not needed. So 60 centimeter minus 10 centimeter coping, so that is height is 50 centimeter, width is 0.3 and height is 0.5. So our total quantity is 0.6, unit is meter square. Now we are going to do this ends of the coping, that means we have 4 number of ends of this coping, that means this portion, and these 2 small portions here and here. So we have ends of coping 4 in number, having the width of 0.4 and the height of 0.1. And while calculating the height, we also need to calculate the small portion projection, that means this 0.1 meter projection. So we have to write the height equals to 10 centimeter coping plus this portion, that is under the side. So our total height is 0.2 meter. Here we have the width of the coping 0.4 and we have to write the height as 0.2 meter, considering this is an underside portion also. So the total quantity is 0.32. Now while doing this, we have not considered this small rectangular portion, so we have to deduct these portions, because while calculating this portion we have calculated all these portions like this, but we have to reduce this small portion from one side and another rectangular portion from another side. So we have 2 numbers of this rectangle and the length is, this portion is 1.5 meter, that is this small portion is 1.5 meter, so length equals to 1.5, and we have to reduce this height, that means the height is 0.1 meter from the ground level plus 1 meter and plus 0.2 meter, that is 1.3 meter. So height equals to 0.1 meter from the ground level plus this portion 1 meter plus 20 centimeter RCC slab, that is 1.3 meter. And we get our total quantity 3.9 and the unit is meter square. In this way we have calculated all the detailed estimate of this slab culvert. If you like the video, please like, share and subscribe.